Welcome to Python Pro, a 30-day workshop by CTC. And today on day 8, we'll be looking on the while loop and its examples. So moving on towards a while loop. While loop is used to run a block of code until certain condition is met. It is similar to the for loop, but while loop is used when you want to repeat a block of code. Say you're not sure of how many iterations you might need, and it runs until the condition uh, becomes false. So the syntax of while loop goes like the while keyword and then followed by the condition and the colon. And with the indentation, we will be giving our statement that needs to be executed. So let us see a small example. Say I have a countdown to display. Say I'm going to count from 1 to 5. So here I have given, I have declared two variables I and n, and my condition goes like I less than or equal to n. I'm going to print I starting from 1. I'm going to print 5 numbers, and I'm incrementing it inside the loop as well. So until the condition fails, until there is the I goes to 6 and 6 less than or equal to 5 comes and the loop breaks out, we'll be printing from 1 to 5. Moving on to the difference between for loop and while loop. Looking on to the syntax, we have the for keyword and the variable, and the in keyword and the iterable over here. And as far as the while loop, we have only the while keyword and the condition. So the initialization and increment part, automatic initialization and increment based on the iterable. So looking over here, for loop is mostly used to iterate over a sequence or say it is a predefined sequence. Say we have a list or a tuple or a dictionary. It is predefined already, and then this variable takes each element or a value in that sequence, and it runs until that sequence is exhausted. Say there is no more elements in the sequence, it runs till that. So it is automatically initialized, and incrementation is default in for loop as 1, and the termination condition is where there is no more elements in the sequence. So it is all predefined in the for loop. Whereas in while loop, the initialization, incrementation, as well as the termination conditions all are defined by us. The termination condition is what we give in the say the while condition we have given in the syntax. This termination condition is what we are mentioning here, and the incrementation and initialization part goes into the body of the while loop. Else, if we don't give any incrementation in the while loop, it might end as an infinity loop where it keeps printing and printing and there is no stopping. Like the condition does not go false and the code block does not come out of the loop. And the use cases for loop is going to be when you know the number of iteration prior. Say I have a list with 4 elements. The list is going to run only till 4 times if I want to print the list. And it is used only for iterating over a sequence or range. Whereas while loop is used when I'm not sure of how many times I want to run a block of code. That is when I will be using the while loop. Let us look at while statement using a few examples. So consider this flowchart where we have a start state and it goes into the condition. It checks if the condition is true. If it is true, it is going to execute the statement. And again, it is going to check if the condition is true. Until this condition fails, it is not going to stop. So taking an example of, say I have I as 1, I have declared I as 1, and my condition is going to be I less than 10. And while I is going to be less than 10, I'm going to print, say, I'm going to print I, say, I'm going to print, I'm going to print I. Let us have the same. So this condition is going to remain true forever. So I is going to be always less than 10. So if I'm going to print I, it is going to be 1, 1, 1, 1, 1, and it goes on and on and on. This condition never fails. And this is why we are supposed to give an incrementation or decrementation inside this statement itself. Say I'm going to give I equal to I plus 1, and when this occurs, Ri gets incremented once the statement is over. Say once my statement block is over, I want to print I, and then I give I is equal to I plus 1. So while this enters the loop for the first time, it is going to be 1, and it checks the condition. While it is going to check the condition, I will be changed in 2. So say I have my variable is I as 1 over here, and then now it is 2. So it checks now 2 less than 10, and the condition is true, so it prints. Now again it increments to 3, and it goes on and on and on till say 9, because when I becomes 10, 10 less than 10 is going to be false, and it goes to the end state. Similarly, say I want to print the tables, say I want to print 2 tables or any tables, we'll declare something called n and get the input. Say I want to print the 2 tables, so we have 2 over here. And how do I do this with the while loop? So I have an incremental variable called I, and my first condition is going to be like I less than 10, so I want to print till 10. So now let us just have I as 0. No, I is 1, because we don't start tables from 0, so let us have it I from 1. So our while loop condition will be like I less than or equal to 10, because I want to print the numbers table till 10. Say 2 into 10, I want till 2 into 10, and my condition blocks would be, say I want to print n into I. I'll be printing n into I, and then I will be plus equal to 1. I'll be incrementing I by 1. So now my first, say it enters the loop, checks if I is less than or equal to 10, condition is true, 1 is less than 10, so condition true, moves to the statement, prints 2, increments I, checks the statement again, 2 less than equal to 10, yes, then it prints 2 into I, so which is 2 into 2, and again it goes on and on and on until I gets into say 11. When I becomes 11, 11 less than or equal to 10 becomes false, and it exits the loop. So these are a few examples. Let us see a few more examples. So how to find sum of all elements in a list? So let us consider a list. Say 1, 2, 3, 4. And how do I get the sum of all this? So let us have a variable called s that stores the sum. I'm declaring it as 0. And I have an I for the incrementation, so I am going to give it as also 0. And the list, I'm going to save it as A. So to find the sum of all elements in a list, you're going to iterate through the list and add each value here to this sum. So we'll be implementing this using a while loop. So our condition will be like till this, the loop is going to run till the list is out of values. So say the list does not have any more value. So while, and my condition is going to be like I less than, so the condition I can pass on here will be I can iterate it only till it till the length of the list, right? So let me have the length of A. My variable should be less than the length of A. So I need to have I have to iterate it till the length of list. So that is what it means. And we'll have a while condition. And inside while, what am I going to do? I'm going to I'm going to take the sum of each element, which means I'm going to add each element to this variable called sum. So A of I, I'll be adding A of I to sum each time. So S plus or equal to A of I. And then now I'm going to increment I. So I plus or equal to 1. And here in my example, my list has 4 elements. So this while loop is going to run till, let us say, for 4 times. My I is 0 currently. 0 is less than 4. True. It prints, it adds. So if you're going to ask me where can I print this, outside the while loop we can give our print statement, print of s, which is sum, and this will help us to print the whole sum at the end rather than giving. If I'm going to give print here, this is going to print the sum each time. Say if I'm going to add my value first, it is going to be 1, and then it will add these two sum, and that is not the desired output that we want. So we are going to give our print statement down here. Initially our I is going to be 0 and 0 is less than 4, true. A of I gets added to S. A of I is nothing but A of 0. So S will now have 0 plus 1. Now I is incremented to 2. It comes out of loop, checks, I is 1, not 2. So it comes out of loop and it checks 1 is less than 4. Condition true. Now the current S is going to be 1. So 1 plus, what is A of I? A of I is going to be 2, which is A of 1 is 2. And I is incremented to 2. Again comes, checks the value, true. Now that our S value is going to be 3, and A of 2 is also 3, so we have our sum as 3 plus 3. Again increments I to 3. Checks if the condition is true. Again our S is now 6, plus we have our A of 3 as 4. Now we have our sum as 10, and our I gets incremented to 4. The condition fails and it comes out of the loop. While printing S, our sum is going to be 10. Moving on to the Armstrong number. So the condition I can pass on here will be, I can iterate it only till the length of the list, right? So let me have the length of A. My variable should be less than the length of A. So I need to have I have to iterate it till the length of list. So that is what it means. And we'll have a while condition. And inside while, what am I going to do? I'm going to I'm going to take the sum of each element, which means I'm going to add each element to this variable called sum. So A of I, I'll be adding A of I to sum each time. So S plus or equal to A of I. And then now I'm going to increment I. So I plus or equal to 1. And here in my example, my list has 4 elements. So this while loop is going to run till, let us say, for 4 times. My I is 0 currently. 0 is less than 4. True. It prints, it adds. So if you're going to ask me where can I print this, outside the while loop we can give our print statement, print of S, which is sum, and And this will help us to print the whole sum at the end rather than giving, if I'm going to give print here, this is going to print the sum each time. Say if I'm going to add my value first, it is going to be 1 and then it will add these two sum, and that is not the desired output that we want. So we are going to give our print statement down here. Initially our I is going to be 0 and 0 is less than 4 true. A of I gets added to S. A of I is nothing but A of 0. So S will now have 0 plus 1. Now I is incremented to 2. It comes out of loop, checks, sorry, I is 1, not 2. So it comes out of loop and it checks 1 is less than 4. Condition true. Now the current S is going to be 1. So 1 plus, what is A of I? A of I is going to be true, which is A of 1 is 2. And I is incremented to 2. Again comes, checks the value, true. Now that our S value is going to be 3 and A of 2 is also 3, so we have our sum as 3 plus 3. Again increments I to 3. Checks if the condition is true. Again our S is now 6, plus we have our A of 3 as 4. Now we have our sum as 10. And our I gets incremented to 4, the condition fails and it comes out of the loop. While printing S, our sum is going to be 10. Moving on to the Armstrong number. Moving on to Armstrong number, an Armstrong number is a number where, say you take an example of 153, this is an Armstrong number because sum of cube of its digit results in the same number. So 1 cube is 5 cube plus 3 cube is equal to 153. So how do we write logic for this, if you're going to ask me? Each time what we are going to see, how do we get each digit from here? One way is that we divide this number by 10. We are going to get the last digit as a reminder. If you're going to ask me how, take this as A. So A mod 10. A mod 10 will give you 3 because 153 divided by 10 will have 3 as a reminder. Since mod gives us the reminder, and after which we can store this result as its cube, say 3 into 3 into 3 in another variable, say sum. And lastly, we can use the floor division, say 153 by 10. So this is going to help us remove the last digit, because once you divide, it is going to give us decimal value, and in floor division the decimal is removed and it is given to the nearest integer. By following this again and again, say till the number of digits in the given number, we will be able to figure out if this number is an Armstrong number or not. So a refined version to our logic goes like this. Say our temp is going to be the number that we have, say 153, and I have two more other variables. This B is going to store my reminder that I get from mod 10, which is, say, let us just dive into the loop. So 153 is greater than 0, true, condition true. We are going to the first statement where D is equal to 153 mod 10. 153 mod 10. This is going to give me the reminder. Reminder is going to be 3. 153 divided by 10 gives me 3. as reminder. And now that the sum function is going to store sum is going to store my value of 3 cube. Say 3 cube is going to be 27. We are going plus equal to, this is going to be s equal to 27 over here. And then 10 floor division by 10 is going to give us the quotient excluding the remainder, which means 153 by 10, the quotient is 15. So my temporary variable, say temp, is now going to store 15. The temp that I declared above the while loop is now changed to 15 using the floor division, because I have found the cube of the last digit, and now I want to eliminate this last digit and move forward to the other digits. So to eliminate this last digit, we are using the floor division. So once that is done, we are moving and checking again the condition. Now 15 is greater than 0, condition true. Again, D is now going to store, say D is now going to store 15 mod 10. 15 mod 10 is going to give us 5 as remainder, and this sum is now going to store 5 cube. 5 cube is 125, but since it is going to be s plus or equal to, s already has 27. Now we are adding this 125 to the 27, which is going to return us this 27 plus 125. This is going to return us 152. And moving on to the next step, we have temp floor division 10. So 15 floor division 10 is going to give us 1. Say 10, 15. Okay, 10 1 times. So this quotient is 1. So now temp is going to be 1, 1 greater than 0, condition true. Again, you're going to check, you're going to have 1 mod 10. 1 mod 10 is going to give us 1 only. So 1. And then you do the cube, you find the cube of it. 1 cube is 1. And now you are going to add it to the sum. Sum already has 152. Now it is going to be 152 plus 1. Now sum is going to have 153. So now that we have done all this calculation, our sum is going to be 153. Now checking if sum is equal to the number that I gave earlier, which is 153. 153 is equal to 153. True. So this number is an Armstrong number. So now that we know the logic, how to implement it, say for this we won't be requiring any loops. So right away we can check it using an if condition where, say, I've stored it as s, my string is stored as s. So s is equal to s of, I'm going to use my slicing logic over here. So basically what this means is that my first and the last, say the element of the first element, the last element are same. I'm comparing if both are same. Say R and R, A and A, C and C, and then E, the middle element, is not an issue. So if this is going to return true, then I'm going to print yes. If not, I'm going to print no. Say I have race and then I give double E and R. This is going to check, and it is going to fail over here right away because C and E say I put triple E. So C and E are not matching. So this is not a palindrome. So to check if a number is a palindrome or not. Say we have 121 as a number, say n equal to 121. Similar to Armstrong number, we are going to use modulo function, say n mod 10. This is going to return us the last digit. So say here we will be having it as 1. And next we will be storing this number to another variable, say another dummy variable as d. I'm going to store it as at d, but with a slight variation. Say this is at my 100% and this is at my ones place. So we'll be having say d into 10 plus the number. So this adds the digit to the reverse number, and it thus helps us in building the reverse of this number. We are basically trying to reverse the number and check if both are same, if the number when reversed gives the same number or not. And then at the end, what we are going to do is that, similar to Armstrong number, we are going to use floor division and remove the last number. So n floor division 10, this removes the last number. So let us check of how this works. So let us move on to the loop over here. So my number right now is 121, greater than 0, condition check. Now it is going to go to inside the loop, say where d stores num mod 10. Num mod 10 is going to return me 1. The remainder as well as the last digit, both are same. So d stores 1, and over here r is going to store the reversed number which I have declared outside the loop. So r right now is 0. But what I have declared the logic over here is that r into 10 plus d. So right now r into 10 is going to give me only 0, but my d is 1 that I have calculated in the above step. So currently my r is going to be 1. And now floor division 10 is going to give me, is going to remove the last digit for me, because it returns the quotient and it leaves the remainder. Say 121 10, this is my quotient, so num mod 10 gives me the quotient. So currently my num is going to be equal to, say, num as n. Assume num as n, so num is going to store 12. Again it is going to check if 12 is greater than 0, condition is true, it is going to enter into the loop. So d is going to return me the num mod 10. Num mod 10 is nothing but 12 mod 10. This should give me 2 as reminders. So d is equal to 2 now. R is equal to same r into 10 plus d. So r currently I have it as 1. So 1 into 10 plus d. So which is going to be like 10 plus d over here is 2 for me. So 2. So now my r is 12. Removes the last digit and it gives me 1. So currently my num is also equal to 1. It goes and checks the while. If 1 is greater than 0, condition is true. It enters again the d, where 1 mod 10 gives me 1, and r is going to store, r already has 12, so 12 into 10 plus d. D here is 1. 12 into 10 is going to give me 120, and now 1. R is going to have 121. Sorry, R. So now I have my R. I can check if R is equal to the number. If this is going to return me true, then the number is a palindrome. Else it is not a palindrome. So let us implement this code for the sum of elements in a list. So as we discussed, we'll be declaring an array or a list, and then we have two other variables, one for incrementing and one for storing the sum. So I mean one to iterate as well as to increment. I'm checking that this I is less than the length of A. And if this condition is true, I'm going to add each of the index, uh, each of the element in the list called A to this sum. And finally, once this condition fails, say I less than length of A gives me false, that is when I becomes 6 and 6 less than 5 gives us false. It has to print the sum. Let us see if it works. So it has returned us the sum of all the elements in the list. So now checking if a given string is a palindrome or not. So I'm getting a string from the user, and I'm storing it in a variable called string. And using the slicing method, I'm reversing this string and I'm storing it in another variable called r. And I'm going to check if the both are same using the equal to operator. So let us see if this code works. So say I have a string called madam. So this is a palindrome. So to check if a given number is a palindrome or not, as we discussed, I'm getting the input from user and storing it in the num. I have another temporary variable that takes the same value as number. And to store the result of reversing the number, I have declared another variable called rev that is going to be containing the reversed value. And our while loop contains our logic. And at the end, we are going to check if the temporary variable that is storing the number value and the reversed variable are same. Let us see if this code works. Say I'm going to give 1, 2, 2, 3, 1, 2, 3. So this number is a palindrome. And the third problem, we have the Armstrong number. So I'm getting the input from the user and I'm storing it in a variable called num. And to check the length of this number, say the number of digits this number is going to contain, I'm going to convert it to a string and then check its length and store it in another variable called order. And then we have the sum that is initialized to 0 and yet another temporary variable that stores the same value as the num. And our while loop contains our logics that we discussed. So if the num and the sum are equal, so that is the main concept behind the Armstrong number. If the sum of cube of digits is equal to the same number, then it is a palindrome. Else it is not. Let us see if this code works. One. So this number is an Armstrong number, the 1634. Let us see if there are any other number that we can give as input and check if it works. So again, say I give 1, 2, 3. This is not an Armstrong number.